Welcome to GatePoint. So, I'm Amrita and I'm currently in the final year of my M.tech research from Indian Institute of Science, Bangalore. So, this lecture series particularly will be kind of in depth, but I'll try to keep it as concise as possible so that everyone who is in either undergrad or willing to prepare for GATE, you will be able to get an essence of every topic while, you know, doing it in sufficient time, right? So I'll be starting with the first topic in algorithms, that's divide and conquer. So yeah, let's take a look. So in case of divide and conquer, the first thing that I'll hope that you guys will have a knowledge of is asymptotic notations, because we'll be analyzing the time and space based on like each algorithm. So you should have some idea of asymptotic notations before you carry on with this lecture. And another thing is having some basic knowledge of algorithms. And let me just give you a brief overview that, for example, why do we select different algorithm for different problems? So it's very important to keep in mind that we have two resources that we want to kind of preserve. So first is memory and second is time. However, nowadays, since we have kind of sufficient memory, we focus more on the time aspect of it. So we want to reduce time as much as possible and keeping the memory feasible, right? So let's take a look at the divide and conquer algorithms. First, we'll see an example, and from there we'll see what is the difference between the brute force and the divide and conquer algorithm, and why we are willing to use the divide and conquer part, right? So we should always keep in mind that time and space are like goes in kind of, you can see, inversely proportional. So if we want to conserve one, then it most likely is on the cost of the other. So let's take a look at the first example. So it will be the exponential problem. That is, we have two integers as inputs, say p and n, and we want to compute p to the power n. So here we can see we have the inputs p and n, and the output is p to the power n, right? So we are considering both of them as integer. So the two algorithms that we are looking at is, first is the brute force and the second is divide and conquer. Brute force is what we kind of intuitively come across, है ना? So first thing, when we see that we have p to the power n, what comes to our mind is, first is take a for loop of 1 through n and just multiply it iteratively. So that gives the result correctly. However, we see in this case that the space is order of 1. Just a minute. So the space is order of 1. However, the time is order of n. However, since I told you that we will always try to give importance to time, what happens in divide and conquer? Let me just explain this algorithm in kind of a tree form to you so that you understand better. You can take a look at the algorithm and we'll just see diagrammatically what's happening. So if we have, say, p equal to 2 and n equal to 8, right? So what we want to compute is 2 power 8. This can be broken down into 2 power 4, 2 power 4. Why? Because 2 power 4 into 2 power 4 equal to 2 power 8, right? So this thing continues, and at the end we have 2 power zeros, right? What we can see is everything is being repeated. So this same thing, as written in the form of recursion, is done as 2 power 8, from there 2 power 4, then 2 power 2, 2 power 1, and 2 power 0. Okay, after the recursion step we go back. So when we are returning, what we do, 2 power 0 is 1, so we return 1 into 1, that is 1. From here we return 2 into 2, that is right 4, and from there we return again 2 power 2 into 2 power 2. From here we return 2 power 4 into 2 power 4. So this is our final answer that we get. Now in this case, if we analyze the time will be going through the length of the path taken, right? So the length of the path is order of log of n. And for this I told you that you will be requiring some asymptotic notations concept. So if you understand, well and good, else I'll try to make another video for it. Okay, and here but we see that what is the space complexity. Space complexity is the input space plus the space required during the computation. So in the input space we have order of 1 because just two integers, whereas in the computation space we have the stack. So in the stack there is we have to store this 2 power 8, 2 power 4, 2 power 2, 2 power 1, 2 power 0, all has to be stored in a stack during the recursion. So in the space complexity also we get order of log of n, right? So we see from here that when we're trying to improve the time, our space is increasing. However, as I've told you that it's always our first priority to reduce the time because space is kind of more available to us right now, है ना? So log of n is not a very big space complexity, so it's a very good algorithm in real life. So this kind of gives you why we are doing divide and conquer. The same problem we are solving in two different ways and we are getting two different complexities. First thing that we do in any divide and conquer algorithm is divide. Here how did we divide? We broke every 2 power n into 2 power n by 2. So we are basically dividing the n, right? Second step is recurse. What do we do in the recursion step? In the recursion step, we have the kind of after dividing how the algorithm is going to go forward. So basically here the recursive step determined that we'll be going from 2 power 8 to 2 power 0, and then after the recursion step we have the computation part. So while returning from the recursion to the previous recursive step, we are doing the multiplication operation. Therefore, the third step is combine. In combine, what we are doing here, we are multiplying and bringing each of the two parts together with multiplication. So the third step may or may not be necessary. Like there are some algorithms which do not have the combined part. So we'll take a look into different kinds of algorithms. And so this is the basic knowledge kind of about divide and conquer and just an introduction. So you can, like if you like, you can follow the further videos. Thank you.